Take it down here.
So everybody say hi, Lindsay.
Hi,
Lindsay. So we're going to take a look at numbers 22 and 24 and see what we can do with them. Now, I have to say, these circuits are interesting problems. I get the sense that the person who wrote these problems was not an electrical engineer, because the values of voltages and resistors are not typical ones that you would find in circuits. But, you know, there it is. What we have here, now he does his power supplies a little different. Did everybody figure out that the two separate size lines are the same as the lines that I've been drawing like so? Right. Okay, and so this fellow is 250 volts. That's just a little excessive. But you ain't seen nothing yet, because that one's 500 volts. And this guy is 1,000 ohms. And this guy is 2,000 ohms. And this one is 4,000 ohms. And this one is 3,000 ohms. And now what they want to know is the magnitude and direction of the current in the horizontal wire between A and B.
So basically the bottom one.
Bottom one. This current right here. Maybe it goes the other way. That's a good one. Okay? And since we have been doing Kirchoff's laws, we're going to do Kirchoff's laws again today. But we could do this with series and parallel if we were very, very clever. Because there are two resistors here that are in parallel. Who sees them?
The 4.
Yeah, the 4,000 and 3,000 are in parallel. Why? They're connected here, and they're also connected directly right here by the bare wire. So I could reduce these down to their parallel equivalent, and that might make things a little easier. All right, so but let's do it with Kirchoff. Okay, so I need to pick a point here. Let's call that, let's take that point at the top, point A. Actually, they've already labeled it, haven't they? They labeled it C, so let's take their labeling. And we're going to have to guess at how the currents go. I think it makes sense to guess that the current would go this way, so that's I1. And the current would go this way, I2. And then come down I3 and I4, just like that. And then this guy we'll call, I guess, I5. Yuck, are we really going to have 5 equations and 5 variables? No, we might. But if we do, I'm going to show you guys a way to get the answer directly from calculators so that we don't have to do elimination with 5 equations and 5 variables. Wouldn't that be nice? Okay. So if I do the sum of currents at point C, then what I have is I1 going in, I3 is coming out, I2 is going in, I4 is coming out, and all of that adds up to 0. Everybody agree? Yes, no?
Why are there 5 not 24?
Well, we're at point C. Does I5 go into or come out of point C?
No.
No.
Did we just choose C because it has the most points from alphabet?
Yeah, pretty much. Let's pick point A over here. We would say that the sum of the currents at A is equal to, let's see here. This is I1, like so. This is I3 coming in here. This is I5 leaving. I1 is leaving. I3 is coming in. And I5 is leaving. And all of that is equal to 0. Also, yes, ma'am.
Can you tell me, can you read again what all the I's are? Because I can't remember.
Sure, yeah. I've got 1, 2, 3, and 4.
Why is why is for E of the I and the C, point C, I2 positive? It's going the opposite direction of I1.
What is the
The question is coming in or going out?
Oh, right.
Right. Okay. Now I could also do the currents here at point E, but if I did the currents here at point E, I would get an equation that is just these two added together. In fact, I'll show you that. If I add these together, I1 and I3 drop out, and I get I2 minus I4 minus I5 equals 0, which is exactly the equation for this guy right here. How did I know that ahead of time? Well, because once I have taken care of these two nodes, the one node that is remaining has to be consistent with the others, which means it has to be a combination of the others, right? So this is as far as I can get in terms of the node law, as far as getting useful information goes. So now we're going to need to do some loops. Let's choose some loops. I don't know. I like this guy. Just like so. And if I do call that loop number 1, then the sum of voltages around loop number 1 is going to be equal to up 250 minus 1,000 I1 minus 4,000 I3. Now let's just double check the signs on these. Why up? Because I'm going from minus to plus on the power supply. Here the current is going this way, and current goes from plus to minus, so I'm going from plus to minus on this resistor. Here the current's going this way, so it goes from plus to minus, so I'm going plus to minus on this resistor also. Minus, minus. Yes, sir.
How do you decide where you want your loop to go?
There is no wrong loop.
Can you like the direction?
No, like, you could have gone like 1,000 or 3,000.
That's what I'm saying. So like, can you go over
How do you
about the
choose your best
negative?
loop then?
Okay.
Yep, sure will. For the power supply, it's obvious, right? For the resistors, this is the thing that students always kind of struggle with, so let's make sure we get this. I look at the current, and the current tells me which side of the resistor is plus, which side of the resistor is minus. And so as I go around the loop like so, I'm going from plus to minus. I'm going to take that as a negative. Same thing here. This current's going this way, so this resistor is plus, minus, minus. Does that help? Okay. Now I'm going to choose another loop here. I'm going to choose this loop right here. I'm going to go this way. Loop number 2. And I'd like for everybody, bless you, to do the sum of voltages around loop number 2. Go. Would have made more sense for you to call this one I3 and that one I4 to go with the resistors. Oh, well. Sorry. And all of those, oh, by the way, add up to 0. Did everybody get that? Good. Okay. Well, we've got 5 variables, but only 4 equations. We need another loop, and that other loop is going to be here. So here's our loop number 3. This, by the way, is the most equations that you will ever have on any of the homework problems. This one is the most those hundred of variables and equations. So if you're thinking, am I going to have to do this a lot? No, you're not going to do this a lot. The reason I chose this one in particular is I wanted to show you how calculator solution can work. So how does that go if I go around the loop like so? So again, my current is going this way, so that means that this resistor is going to be minus and plus, right? Current goes from plus to minus. Here I have no resistors, so that's going to be really interesting. We're not going to have any voltage drop or rise along that wire. We're just going to have current flowing freely. So how does this go? Well, as I go around, I'm going up from minus to plus, so I'm going to go plus 3000 I4. And then, as I continue to go around, I'm going from plus to minus 4000 I3. And all that is equal to 0.
Yeah. Could you just go the other way around?
Yeah.
So then you would have a plus
Yeah.
1000 instead of negative 1000?
We'd have minus here and plus there.
Yeah, which would equal then plus 1000.
No,
Oh, sorry.
no, it's 3000 times I4 minus 4000 times I3.
So it doesn't matter? Which way you go?
No, if you go the other way, you get this equation right here, which is the same equation as that one, multiplied by -1. You get an equivalent equation. Both of them tell you that 3000 I4 is equal to 4000 I3. Okay. All right, now we're going to actually solve this by calculator. And in order to get our equations ready for solving by calculator, we have to set them up in the same way we did for elimination, with all the variables lined up and all the constants on the other side. So let's start by doing that. You guys get your calculators out because you're definitely going to need them. I'm just going to take these equations and copy them to a new page. These guys are ready to go. Okay. That's good. This is almost good. Okay. This one is going to give me minus 1000 I1. Minus 4000 I3 equals negative 250. You guys should be doing the same thing here, getting all your variables lined up, all your constants on the other side. Minus 2000 I2, minus 3000 I4. Equals minus 500. And then $4,000 I3 minus 3,000. Okay. And now we've got all of our equations set up. Now this gets a little hairy here. Let me move my constants over a little further so that we can see them more clearly. So that I have room to put minus I5 out by its lonesome. Okay. Is everybody with me so far? And we understand that if I don't see a coefficient right here, what is the coefficient of I2 in this equation? 0. That's right. The invisible coefficient here is 0. Okay. All right. Now here's how we're going to do this. We're going to think about this as a matrix equation. I have a big matrix, and my big matrix it consists of the coefficients. In the first case, 1, 1, minus 1, minus 1, 0. In the second case, minus 1, 0, 1, 0, minus 1, etc. And that big matrix equation is multiplied by my currents, I1, I2, I3, I4, I5. And the result is this vector of voltage outputs, which is so. Let me give some more definition to this. Okay. Now the way that you would solve this matrix equation, Catherine looks distressed. No, it's actually really nice. Just give it a second. Give me about 3 minutes to convince you that this will be nice. All right. The way that we would normally solve this matrix equation by hand is by doing the elimination process. So this is not saying anything different. It's just using a new notation for it. But here's the advantage. If I could find a way to divide both sides by the matrix A, I could have all 5 of my currents in one step. And that's exactly what we're going to do. We're going to multiply both sides by the inverse matrix A, the inverse of A, so that these cancel and give me the i's directly. All that we have to do is to set it up in our calculator and then tell the calculator to multiply by the inverse. Okay? I will explain exactly how to do it. So everybody turn on your calculators. And I need to pull up my own. Okay. Okay. Excuse me. What we're going to do, I have my okay. You're going to hit second matrix. Everybody see the matrix button right here above x to the minus 1? Right there.
Oh, yes.
Yep. And that's going to give you the opportunity to do 3 things. You could do names, math, or edit. We're going to edit matrix A and after that matrix B. So go over to edit, and we're going to edit matrix A. And my matrix A currently says 1 by 1 here, because I was doing some stuff earlier. My matrix A on this one said 5 by 5. It wasn't for this problem. We're going to change our matrix A to be 5 by 5 because we have 5 equations and 5 variables. When you do, your matrix A gets big. 5 by 5. And now we're going to walk through and we're going to enter the coefficients of all of our variables in the equation. So the first equation goes I1 plus I2 minus I3 minus I4, nothing, equals 0. I'm going to enter 1 for I1, 1 for I2, minus 1, and 0 in that first row. And you just type in the number 1 and hit enter, and it goes to the next one. And 0. And that puts me on the next line. See? I just entered the left side of my first equation. Everybody with me so far? And now you go through and you enter the second equation. So the second equation is going to be minus 1, 0, 1, 0, minus 1. Make sure that I've entered those correctly. Yep.
What are the parameters for second equation?
What's that?
What was the numbers?
Minus 1, 0, 1, 0, minus 1. And now I'm going to enter the numbers for the third equation. Minus 1,000, 0, minus 4,000, right? 0, and 0. I'm not entering the right-hand side. We'll put that one into our other matrix B in just a moment. For the next one, we have 0, minus 2,000, 0, minus 3,000, and 0. And then finally, for our last one, we have 0, 0, 4,000, minus 3,000, and 0. And we're done. It took us a little bit of time to talk through this, but the actual entering of it actually took us less than 60 seconds. Think about how long you would spend doing the elimination, right? So even though this is a little unfamiliar to us, I think we agree that this goes a lot faster and smoother in the elimination process. That's the left-hand side. To do the right-hand side, I'm going to do the same thing, but I'm going to put it into matrix B. So I'm going to hit second matrix again, and I'm going to go back to editing. And this time, instead of editing matrix A, I'm going to edit matrix B. And I'm going to make that matrix B 5 by 1 because I'm going to enter my 5 right-hand side values right here. Should I be doing this on your calculator?
Are they all 0?
No.
No, I think.
They are what you said they were. 0, 0.
Because it's 5 by 1.
Uh-huh. The 5 refers to the rows, the 1 refers to the columns. So it's row column. And 0. And that's all entered. Yes, sir.
Was that quote a reference to Dennis Green by any chance?
What's that?
Was that reference, was that quote you just said they are what you said they are, was that a reference to something?
No. It was just me
Because that's
talking.
what a famous guy once said that in the middle of a rant, and that's what he's famous for saying.
Oh, yeah? Tennessee?
Dennis Green, he was a Bears and a Cardinals coach, but he's only famous for yelling at the Bears winning the Super Bowl. First thing they are what they said, who he said we thought they were.
Okay. I don't know. Okay, at this point we have entered our matrix A, we've entered our matrix B, and we have the equation AI is equal to B. So all that we need to do now is to effectively divide both sides by B, or we'd say multiply both sides by the inverse. Divide both sides by A, or multiply both sides by the inverse of A, and we can do that in one simple step. So I go back to my calculator, and I quit out of all this, because I've got my equation entered. And now what I'm going to do is to literally enter A inverse times B, like so. I'm going to go back to matrix and do the name A. And then I'm going to use the x to the minus 1 button to denote inverse. And I'm going to multiply that times second matrix names B, just like that.
I got it.
And when we do, boom, it gives us an output vector that gives us the entire solution to the whole equation right
Wait,
there.
if I have
Can we show?
Let me do this on mine here. Maybe I entered something wrong.
Should I be in
I
the
got the same as
You got that?
I think not. Should I change if you're grading your degree?
No, like, yeah, this one.
Usually it's going to be a sign error or some other number that's a little different. So let's just check all our matrices. This will give Deja a chance to catch up. You really need to catch up because you want to be able to do this. So get with that so it should help you out here. Let's check your matrix A right here and see if it has the same values. First row should be 1, 1, minus 1, minus 1, 0. Second row should be -1, 0, 1, 0, -1. Third row should be -1,000, 0, -4,000,
I found my wrong.
yep, 0, and 0. Fourth row should be 0, -2,000, 0, -3,000, 0. And the fifth row is 0, 0, 4,000, -3,000, and 0. You got it?
Wait. They're still different than yours. They're different now, but they're still different than yours.
I didn't hear what was wrong.
Now check
I
matrix.
know I'm wrong.
Now check matrix B.
Negative. Yeah, so you're just doing like.
Fail. Now check matrix B. And matrix B should be 0, 0, -250. -500 and 0.
Negative 1,000.
And then to compute the whole thing,
Yeah, sure.
you should have A inverse times B.
Yeah, let's find it out.
Let me see.
Look at this, look at this.
Yeah,
Okay.
he fixed mine.
We have it. She's looking at it.
And I can see this number is really, they not part of the whole brain area.
Okay, at this point, has everybody gotten this solution? Has anybody not gotten this solution?
For edit,
They just get it up.
mean?
What does it mean? Well, what this means is that these are,
Can I see this?
I got it.
right hand side.
I'll write it right here. These guys right here are the currents I1, I2, I3, I4, I5.
Respectively.
Yes.
So we only need the
So
last
0.05,
one.
isn't it?
Yeah, so 0.05 is the answer we're looking for. It is the value of I5. So this guy right here is 0.05. And I can fill in the others if I really wanted to. 0.01 for I1. 0.13 for I2. 0.06 for I3. And 0.08 for I4. And that's it. Yes?
If we do the calculator on the homework, like how do we like?
I don't need to see any of the algebra. So once you have the equation, you can give me the solutions immediately. Now, this isn't, what do you think about this method of solution? Not nearly as scary as it looks, but still a little bit like, could I really do this if I needed to? So if, when you are faced with something unfamiliar, what's the cure for making it familiar? Practice it, that's right. Once you do 2 or 3 of these, you'll be fine. I rate it like this. The setup is sort of a pain, because you gotta go through and enter everything. Once you got the setup, the solution is delightful, because it's automatic. And I don't know about you, but when I do elimination, I tend to make a lot of dumb mistakes.
Oh, yeah. Well, I'll just give us the answer.
Well, the question was, what is the current between A and E? And I labeled that as I5, so the answer is 0.05.
And then
Okay.
when it asks, because it asks for like the direction and magnitude, so would you just like say?
Direction is from A to E.
From A.
Yeah.
So if this was like negative.
Then it would be from E to A. Exactly. That's exactly it. Good. Well, hopefully we can do number 24 a little faster.
Yes, please.
But we're gonna use this as an opportunity to practice our mad calculator skills.
Um,
Yeah, that's
Okay. Mentally, I want you to break this problem up into two parts. We're going to use Kirchoff's laws to get equations. Then we're going to use our preferred method of solving, whether that's elimination or substitution. Heck, you could even do like trial and error guess check if you wanted to. I don't recommend it. Or inverse matrices in order to solve it. We're going to do a practice. We're going to use this to practice with our inverse matrices. All right, so where do I start in setting up the equations? Pick a point, pick a node, any node. Where?
Point.
yes.
I like that. Okay?
Do you have a different amount of nodes?
Yes.
How do you determine how many nodes you want?
Good question. The only nodes that are meaningful are ones that have more than 2 wires coming into them.
Okay.
If I pick any node like here, then this one is just going to tell me that the current coming in equals the current leaving, and I knew that already.
So is that like, what about at the bottom right hand? That's 2.
That's 2. So that's just going to tell me that the current going in equals the current going out.
I think 20 is about, it's 35 and 20.
35 and 20.
Oh, right, I knew that. Okay.
So that's first thing. Second thing is, out of all of the ones that have more than 2 wires coming into them, let's say I have 6 of those. Only 5 of those will give me meaningful equations, because the last one has to be a combination of the other 5.
Okay.
So here I've got really only 2 nodes, so only one of those will give me a meaningful equation.
Okay.
Okay? All right, so where do I go? I've identified a node. Now what? Draw in my currents. That's right. So I'm going to draw in current here going up. I agree with you. I want. How about here? Going down? I too. And then here?
Go to the right.
Go to the right. Yeah.
Is there a reason
How
you
do
did that
I
on the
two
bottom?
going up? Just because she told me to.
Never mind.
We'll keep it as I2 going down. And see
Why
what
not?
happens. Yeah, sure. Yeah. I think their intuition is we chose the opposite direction of the current flow, and that's okay. All right. So now I need an equation for node A. What is the sum of my currents at node A? Somebody, anybody? I1 taken as negative Y
And 2. I2 going up.
Down.
2 down.
Down.
No.
Wait,
So
why
minus
did I go-
I2.
Because I've been
I mean,
wanting it. I've been wanting it.
Out, right,
All-
I am.
Evan wanted it down, so
We're having it down.
we're having it down. That's right. Thus illustrating that it's okay to have an arbitrary choice. Evan is perfectly fine. There's nothing wrong with what you did.
For all we know, I1 could be going up as well.
Okay. All right, what about I3, positive or negative? Negative, because it's going out. Now, already we can see that the only way that this equation is going to work is for at least one of our currents to have a negative value, right? So we know that we chose a direction, one direction that was technically incorrect. It's okay. All right. Seriously?
It's not.
Okay. Now that I've got my node equation, where do I go from here?
Oh, you're gonna do another equation.
I do. Where am I going to get it from? I need a loop. That's exactly it. What should my loop be? Go this way, around where? Here? To here? To here? To here.
Sure.
Okay. I may have misunderstood you, but that's okay. This will work. All right? Let's do some of the voltages around loop 1. This is the tricky part, so let's make sure we get it right. So I walk around, and here I go. What's the first thing I encounter?
Pardon the interruption. I just wanted to let you know they are working on the security systems and everybody can move, so.
What's the first thing I encounter?
20 volt.
The 20 volts, yep. Do I treat that as plus or minus? Plus. Because I'm going from minus to plus. All right? The 30 ohms. Do I treat this as
Negative.
negative? Because I1 is going through it like so. So my resistor is plus to minus like that. Okay. All right, now I keep on going around. Next thing I encounter is the 20 ohms.
Positive?
Which way is current going through it?
That way, so it's positive. Oh.
Right. Current goes from plus to minus, so I'm going to treat this as a voltage rise. And then that brings me back around to the top. Notice that I do not include anything that was not in that loop. So these guys are left out of the equation.
So we don't have to do those if they're not in the loop?
You should not do them if they're not in the loop. If you include them, then you're doing it. All right, well that gets us 2 equations. I need one more equation, so I need one more loop. Where?
Start on the middle, and then just go right, and then down. Yeah.
Like that. Okay, good. Joseph, can you give us the equation for loop number 2?
The sum of B2 equals 10. Gate horizon 10. Minus 5 because it's plus to minus. And then
Minus
I3.
Yes, 5 times I3.
And then plus 30 I2. No, 20 I2.
20 I2.
And equals 0.
And that adds up to 0. That's great. Okay. So we now have our 3 equations. The physics is done. The rest is just a matter of plugging it in to our calculator. To do that, I need to first set it up. And I set it up by having all the variables lined up and all the constants on the right. So let me, all of you, go ahead and arrange your equations so your variables are lined up and your constants are on the other side.
Could we start using matrices like write it out in matrices? I think that would be
Sure. If you wanted to do that. This is practically in matrix form already. Just writing it like this is practically the same as matrix form. If you're comfortable with writing it as a matrix, or even if you're not, I'll show you what it would look like. In matrix form, it simply looks like this.
It could be 3 by 3.
It'd be 3 by 3.
1.
3 by 3 and then 3 by 1. Remember that it's row, column. Oh, that's good. It just took me about 30 seconds to enter the whole thing. Well, that's a great question. How are we going to check this?
Wait, do we have to do the same thing we did last time, the inverse?
Yep, exactly. And per your predictions, look at that. My I2 turned out to be negative, indicating that the other direction is actually the correct direction. I want to take a minute to talk about how we would check this. Let me put my eyes up here. 4.7 and 0.12. Here's the way that I'm going to check this. The first thing that I'm going to check is that all of my currents should add up to 0 coming out of here. And because I'm taking them all as going out, what I'm checking is that minus that, plus minus that, plus minus that adds up to 0. And you can do that in your head. 0.12, 0.35 add up to 0.47. That cancels with the minus 0.47. Our currents are good. So that's the first thing I want to check. Second thing I want to check is to check voltages. And I'm going to do that by picking a point to be ground, a point to be 0. So here's my check. I'm going to start with this point at 0 volts. And then I'm going to go around the circuit and I'm going to label various points and I'm going to look for consistency. If this point is 0, then this point has to be at 20 volts. Everybody see that? This point is going to be 20 minus the voltage drop through here, which is 30 times I1. And 30 times I1 is 10.5 volts. So that makes this point 30 minus, or 20 minus that, or 9.5 volts. Okay? This point is also 0 because it's connected. That means this point is at 10. And 10 minus the voltage drop here, which is 0.15 times 0.12, which is 0.6 volts. 10 minus 0.6 should be 9.4 volts. Hey, look at that. This is consistent. We've got the same voltage right there. Now, the last one's a little tricky because I got a negative current, right? So I'm actually going to sort of reverse this and call that 0.47. And if I go from here to here, my voltage should drop by 20 times 0.47, which is 9.4 volts, so that once I get to here, this point should be at 0, and that's right, because all of these right here are all grounded together. So my circuit is consistent with itself, and I don't even have to look in the back to see if the answer is correct. I have a self-consistent, self-checking circuit. Does that make sense to everybody? Now this is working. Does the calculator approach make sense now that you've done a couple of them? And if you get stuck somewhere, you've got plenty of friends, you can text them and say, hey, how's that calculator thing going? And they'll say, look at the video that's online, and it'll show you.